Hello guys, how are you? This is Hans Hawiya once again. We are starting a new topic, work, energy and power. So these are our specific objectives from our syllabus. By the end of this topic, we should have covered all these specific objectives. So without wasting any time, let's jump right in, okay? Work done. What is work done? Work is done when a force moves an object in its direction, right? The SI unit is joule. Work done is equal to force times distance. So this is the formula for calculating work. So from this formula, W is work done in joules, F is force in newtons, S is distance in meters. So here is an example. The diagram below shows a slide. Here is a slide. Suppose you carry a bag of mass 12 kg, this bag, to the top of the slide. This is the top of the slide. Through the steps. So you are going through these steps, right? How much work will you have done in carrying the bag to the top? The work done. How much work will you have done? So remember, force has to move the object in its direction. So the direction here, when you lift something, the direction is upwards. So this is the force that you'll be applying, right? You are lifting it against what? Gravity, acting on the object, which is its weight. So this is, by lifting it, you are countering the what? The weight of the object. If you release it at this point, it will fall to the ground because the gravitational force is pulling it down. So you are opposing the force of gravity. So the amount of force you are applying here is equivalent to the weight. So first we have to find the what? The weight, which is mg. Weight is equal to mg is equal to 12 kg, because this is our mass, times g is the gravitational strength, which is 10 Newton per kg. 10 Newton per kg, right? Now what do we do? Let's multiply this. The kgs, they cancel out, right? 12 times 10, what do we get? We get 120. And then see, the n for Newton is still here, so is 120 what? Newtons. So weight is equal to 120 Newton. That's the force, right? That's the force you are applying here. It's equivalent to the weight. Then work done is equal to force times distance. This formula here. Then the force is the what? Is equivalent to the weight. This force is equivalent to the weight here. So this force is 120 Newton. 120 Newton multiplied by S. Remember, in its direction. So the force is upward, the distance has to be parallel. This one. This is the distance that we're going to take. 2 meters. Not this one, not this one. Well, it has to be parallel to the force. So that's 2 meters. And then what do we get? 120 times 2. That's 240 Newton meter. Right? Then we are going to write our final answer as 240 joules. The SI unit for work done is joules, not Newton meter, right? So this is the final answer. Let's look at question number 2. Here is question number 2. A box of mass 25 kg is pulled across the floor as shown below. The box moves a distance of 5 meters at a constant speed of 2 meters per second. So the box moves from here to here, right? That's it. Now, questions. If the work done on the box is 250 joules, find the pulling force. So how do we do that? Let's start by writing the data. Mass of 25 kg, right? M 25 kg is pulled across the floor. Distance moved is 5 meters. S is equal to 5. That's the distance at a speed of 2 meters per second. The speed is equal to 2 meters per second. The work done in moving the box through this distance is 250, right? 250. Then A, we are to find the force question mark, right? Then where do we start? We are to find force. Any equation that we can use to find force which has 2 or more of these quantities here, which equation is that? That's work done. Work done is equal to force times distance. Work done is given as 250, force F times distance of 5 meters, right? What do? We divide both sides by 5 meters. So divided by 5 divided by 5. 5 into 5, 1. 5 into 5, 1. Cancel. 5 cancel 5. 5 into 5, 1. Into 25. That's 5 into 0, 0. Right? So 50 is equal to F. Therefore, our force, pulling force is 50 newtons. That's A. Let's look at B. State the value of friction force acting on the box. Friction force acting on the box. Part B. So for part B, I will start by drawing a diagram here to represent this box. Here is a force of pulling force has been determined as 50 Newton. Then we have friction force here, unknown for now. Then what do we know about this? We know that the speed is not changing. It's not changing, right? What can cause the speed to change is the acceleration. Therefore, there is no acceleration, which means acceleration is 0. Acceleration has to be 0, guys, because the speed is not changing. If the acceleration is 0, therefore that which causes acceleration is also 0. So re le ka go se bua gore ka re lebelo la koloi ha le change, go ra re koloi ha accelerate. Ha sa accelerate, go ra re se se ira gore koloi ha accelerate ha se, which is the what? Resultant force. Resultant force is responsible for changing acceleration. Therefore, resultant force is also 0. So if we are saying if this is F1 and this is F2, then we have F resultant force is equal to, it's always F1 minus F2. You find the difference between opposing forces. If the answer is 0 here, that means, okay, maybe before we do that, let's say F1 is 50 minus F2 is equal to 0. So 50 minus a certain number, then we get 0. What number is that? We can take this to the other side, right? 50 minus F2 is equal to 0. Isn't it clear for everyone? So here I am. I'm going to add F2 both sides plus F2. These, they cancel out. So 50 is equal to 0 plus F2. It remains the same, because if you add 0, the number doesn't change. So F2 is equal to 50. So when the acceleration is 0, that means the resultant force is 0. Therefore, the opposing forces are equal. So here we have the friction acting on the object is equal to the pulling force, which is 50 newtons, right? So now let's look at part C. Part C here. Friction force decreases to half its initial value as the box is pulled across a smooth polished tile. So the friction is now equal to, initially it was 25, so from 50 divided by 2 we get 25, so that is 25 newtons. So this is the frictional force. Now determine the resultant force. The resultant force what do we have to do? We have to remember that initially this is what we had, 50 Newton and 50 Newton. So what's the scenario now? So pulling force is still 50, remember, then friction is now 25 Newton. The resultant value of the first two forces acting on the same object, that is just 50 minus 25, which is 25 Newton. It's 25 Newton. So it's here 25 Newton. Roman figure 1. Roman figure 2, find its acceleration. Now here with the resultant force, so F is equal to ma, right? The F here is for what? For the resultant force, remember, always. So what do we do now? Here is 25 is equal to M is the mass, 25 is still 25, remember, 25 multiplied by A for acceleration, right? So what do? We divide both sides by 25. 25 both sides. 25 both sides. 25 cancels 25. That's 1, 1. 25 into 25, 1 into 25, 1. 1 over 1 is 1. This one is equal to A. Therefore, acceleration is 1 meter per second squared, right? 1 meter per second squared. So it's here 1 meter per second squared. So let's look at Roman figure 3. Let me clear this space. Well, Roman figure 3, determine the velocity of the box after covering 10.5 meters across the smooth tile. And we are going to remember a few things. After on the smooth tile, A is equal to 1 as calculated here. What else? Distance. The distance, I have to do this because this data now is different. This is for moving across maybe say a rough surface, but here is now the distance across the polished smooth tile. The distance now is given as 10.5 meters. Determine the velocity of the box after covering 10.5 in the smooth tile. V is the question mark, but the initial velocity at the beginning, because we have the smooth tile here, right? It starts here, A, maybe up to here, B. The length here is 10.5, but there is a point here. This is the polished one. Before, remember at this point the speed was this one, 2 meters per second, but when it got here, now the speed was increasing. The speed was increasing by 1 meter per second every second. Then, having said that, that means the initial velocity is 2. This is the 2 at this point here. We started at 2 when we started the surface, smooth tile surface. But the final velocity at the end here is not known, right? This is what we are going to try to determine here. Okay, let me just take the long route. I'm going to write down all the equations of motion here. So let me start. First things first. H is equal to U plus V divided by 2 multiplied by time. Then we have S is equal to U T plus half A T squared. Then we have V is equal to U plus A T. Then we also have V squared is equal to U squared plus 2A AS. So these are the formulas that we choose from. We are going to choose from these, right? Let's start here. Let's start here. Or we can start anyway, really. Let's start here. We don't have the final velocity. Oh, actually, final velocity is what we are looking for. We are very happy we have final velocity, but we don't have time. We can't be trying to find two quantities using one formula, right? So we can't use this one. How about this one? To start with, it doesn't have V, but we are to determine V. So we're not happy with this one straight away. Then this one, there's V here. If we have U and AT, we can use this one, but we don't have time. We're not given time, right? So we cannot use it. So how about this one? Yes, V is here. We have U is here. We have 2 is just a constant. Then we have A. Then we have S. Oh, wow, good. This is the formula that we are going to use. That's great. So let me see. This is the formula, right? V squared is equal to U squared plus 2AS. V squared is equal to U squared, that's 2 squared plus 2 times A. What is A? A is 1. 1 times S. What is S? Is 10.5. 10.5. So what do we have here? V squared is equal to 2 squared is 4 plus 2 times 1 is 2 times 10.5. That will be 21. That's 21, right? 21. Then V squared is equal to 25. What do we do when we get here? We take the square root both sides. Square root both sides. The square root cancels the square because we are not looking for V squared, we are looking for V, right? So square root of 25, that's V is equal to 5 meters per second. So this is the final answer. Okay, so now let's look at Roman figure 4. Roman figure 4. Calculate the time taken to cover 10.5 meters on the smooth tile. On the smooth tile, we are to determine time. So here we have V. We found V to be 5, right? So to determine T, we can use this formula. V is equal to U plus A T. Right? What is the value of V? Is 5. Then that of U is 2 plus A times T. Let's use a different color. So, this is 1, remember. This is 1. This is just 1. I'm just going to write on top here. This is 1. And 1 multiplied by T, it doesn't change anything. So 5 is equal to 2 plus T. What do? We subtract 2 from both sides, right? Minus 2. Minus 2. Yes, minus 2, because this 2 has to disappear. So cancel out, it becomes 0. Then 5 minus 2, that's 3. 3 is equal to T. So T is equal to 3 seconds. 3 seconds. 3 seconds. Roman figure 5. Sketch the speed time graph for the last 10.5 meters. Remember what we are expected to include, right? The first thing is to label the axis, time in seconds. Then we have the speed here in meters per second, right? Time from 0. Then what we have for the last, this is while the speed is changing. While the speed is changing, so it's changing constantly. The acceleration is constant. So this is 2. This is final velocity is 5. So this is initial velocity, this is final velocity. From initial to final, time taken is this one, 3. So this is how you are supposed to sketch. Remember, you are going to use a ruler here, a ruler, and here also, because it's a straight line, you are using a ruler. It's not a curve. Okay. Well, question number 3. A woman carries a bag from the shop with items weighing 50 Newton from a local store, which is 2 kilometers from her home. Can be his again. From her home, right? Find the work done by the woman on the bag of sugar over this distance. Well, here is the bag. Its weight is 50 Newton, and therefore the force applied by the woman, it has to be 50 Newton as well. And where is she going? Where is she going? In this direction. Distance is 2000. Let me just write this in meters. 2000 meters. Look, the force is going upwards, the distance in this direction. They are not parallel. They are not in the same direction. Therefore, no work done in lifting the bag over this distance. No work done. No work done. Good.